Hello students, welcome to Soras's classes. In this video, I will be solving the following question from ISS 2015 paper 2. Now, in this question, we have to explain how Rao-Blackwell theorem helps one to a uniformly minimum variance unbiased estimator, that is UMVUE. So we have to understand how this Rao-Blackwell theorem it helps one to a uniformly minimum variance unbiased estimator, or UMVUE in short, of an unknown parameter, and then what is the relevance of Lemonce theorem in this scenario. Now first, this Rao-Blackwell theorem This Rao-Blackwell theorem, it is a way to improve efficiency of initial estimators. So it is a way to improve the efficiency of initial estimators. Now this theorem, that is the Rao-Blackwell theorem, it says that the conditional expected value of an unbiased estimator, so the conditional expected value of an unbiased estimator given a sufficient statistic, this is another unbiased estimator that's at least as good. So this conditional expected value of an unbiased estimator given a sufficient statistic is another unbiased estimator another unbiased estimator that's at least as good. So basically the estimators obtained by the Rao-Blackwell theorem or Rao-Blackwell estimators, they are better than the estimators that we initially start with, because the estimators that we initially start with, they are very crude in nature. So the estimators or Rao-Blackwell estimators, these estimators are better than the estimators that we start with. So this Rao-Blackwell theorem, it provides us a way to improve the efficiency of initial estimators. Now this conditional expected value of an unknown or unbiased estimator given a sufficient statistic, this is another example or another unbiased estimator that is at least as good as the estimator. So this Rao-Blackwell theorem, it helps us to obtain an estimator that is at least as good as that estimator. Now next is this Lemonce theorem. Now this theorem has an additional hypothesis. So it has an additional hypothesis, and that is that the sufficient statistic, so it is that the sufficient statistic is complete. So the sufficient statistic is complete, so that is it admits that there is no unbiased estimators of 0. So it admits that there is no unbiased estimators of 0. It also has an additional conclusion that the estimator we get is the unique best unbiased estimator. So it also has an additional conclusion. So it also has an additional conclusion that the estimate we get is unique best unbiased estimator. So estimator we get are unique best unbiased estimator. Best unbiased estimator. Now, when an estimator is complete, then unbiased and sufficient. So when an estimator is complete, unbiased and sufficient, in that situation, so when the estimators they are complete, unbiased and sufficient, then it gives or it results in best possible unbiased estimator. So this is the relevance of Lemonce theorem in this scenario.